Okay, now we get to next instruction, which is move the 0 to RBP minus 20. We look at our layout. This is RBP minus 20, right? If I copy it, look at this address in here to see the content at this address, and because it says a Q word, so we say 8 bytes. I want to represent them in the hexadecimal. If I hit enter, you see we have a lot of bytes in here which are just garbage. So this instruction, what it says is that put 0 for all of these 8 bytes so that you would remove all the garbage. So if I just say step I, so you see when I say info registers RIP, it says we are currently at this address 4659, which is exactly this one. So I say step I and then have a look at this memory address, and as you see, all of them have been changed to zeros. So therefore the memory layout says that we have 8 bytes of 0 in here. Well, I'm not going to write all of them, but we have all zeros until we reach this memory address. Now next one says now do this for RBP minus 18. If we have a look again, RBP minus 18 in hex is this one, right? This is RBP minus 20 in decimal. So I copy it, look at the GDB, I say what are the values in here before we execute that instructions. Again, bunch of garbage values. I say step I, then have a look at all of these 8 bytes. They all have been zeroed out too. Now next instruction. So next instruction says look at RBP minus 10. Well, this is RBP minus 10 or minus 16, right? Because 10 in hex is equal to 16 in decimal. I copy this, look at the debugger, X, let me have a look, XB, then paste it in here, hit enter, we have got some garbage. I say step I and then have a look. Now if you look, we have 4 bytes of 0, but then we have this value that haven't been changed. We have 0FF and 07F. The reason for that is this third instruction, which instead of Q word, it says look at the RBP minus 10 and move zeros into this memory address, but 4 bytes after that, because D word means 4 bytes. So instead of 8 bytes, it says 4 bytes. Therefore, we would have, well, you know, all of these places, we have 00 to 8 bytes until we reach the E1, A0, right? So what it says is that E1, A0 would be equal to 0. Then we have E1, A1, which is 00. Let me just write them in here. So we have E1, A0, then we have A1, A2, and A3, right? All of these would have the value of 0, but then we get to this one. We get to, let me write it down. So after 4 bytes, we get to E1, A4. And the difference between E1, A4 and E1, A8 would be 4 bytes. So these 4 bytes in here, they haven't been zeroed out. I don't know the reason. If I just copy this and have a look at the debugger, you see even A3 would give me, or let me just look at it in 1 byte. This would be, sorry, this would be 1xb. So this is 0, but A4 is another value. Also A5 is another value, and actually A6 and A7, they are 0 by just by accident. So I don't know why it hasn't changed the values between E1 A4 and E1 A8, which is 4 bytes, to 0, even though it has put zeros for all the other bytes, but it hasn't put 0 for these 4 bytes in here. Maybe that's an error with compiler, which I don't think so. Maybe we don't know the reason, but well, we could search what is the reason for this. Anyways, we have now we have make our bytes in the stack completely ready for ourselves to pass these values into the memory addresses.